The video is now recording, okay? The audio is recording. So today what we're going to work on, yes? What we're going to work on today is we're going to work on the applications for the systems of linear equations. So the first one that we're going to work on is number 1. The sum of two numbers is 30. We're going to let number 1 be x and number 2 be y. So x plus y is equal to 30. It says here that their difference, the difference of those numbers is 12. X minus y is equal to 12. So now we have our system. This is back to what we've been working with. This looks very similar to what we've had. So what do we want to do first? What's the first thing? Elimination. We want to eliminate a variable. Okay, so elimination of a variable. Which variable would be the best one to eliminate? Y. So we are just going to add these together, and we get 2x. X plus x is 2x. Y minus y is the 0y that we were looking for, is equal to 42. This leaves us with 2x is equal to 42. We're going to divide by 2. Divide by 2. X is equal to 21. That is one of our numbers. X is equal to 21 is one of our numbers. We've got to find the second number. So what we want to do at this point is we want to substitute x is equal to 21 into either one of these equations. What's going to be the easiest equation to substitute it into? The first one, because they're all positive, okay? Whenever you have an opportunity to work with all positive numbers, work with positive numbers. And whenever you have an opportunity to work with negatives, try to choose the positives, okay? So here we see that there's at least one negative. These are all positive. We're just going to choose the positives into the first equation. So what we have is what we have here is 21 plus y is equal to 30. Subtract 21 from both sides, and we have y is equal to 9. The two numbers that we were looking for, 21 and 9. The two numbers are 21 and 9. So that takes care of the first one, okay? So let's go ahead and have a look at the second one. So the second question says, the sum. What does the sum mean? When it says the sum of two numbers, what does that mean? You add them. It's the addition of those numbers. The sum of two numbers is 24. The difference of those same two numbers is 2. So let's write it up just like we did the first one. So the sum of two numbers is 24, so x plus y x plus y is equal to 24. The difference of those same two numbers is 2. X minus y is equal to 2. We want to eliminate a variable. Which variable is the best candidate to eliminate? The y's. One's positive, one's negative. There's nothing we need to do. We just add them directly together. So eliminate the y's. We're going to add these two together. X plus x
2x.
is 2x. Y plus negative y
0y.
is equal to 26. This leaves us with 2x is equal to 26. Divide by 2, divide by 2. X equals 13. So that's going to be one of our numbers. So as with the first problem that we did, we substitute x is equal to 13 into which one of these? Into the first equation, because they're all positive numbers. So we have 13 is equal to 24. Minus 13 from both sides. Y is equal to 11. So the two numbers are 13 and 11. Let's work on number 3 now. So number 3, again, all you have to be doing here is following along, writing down what I'm writing, and you're going to get a classwork grade, a participation grade for today, okay? And of course, you're going to be able to ace your homework for tonight, so, or for the weekend. So just follow along.
It's easy, right?
Well, it's going to kick up a notch now with these other problems, okay? So, but again, the difference between two numbers is 9. How do we set that up? The difference between two numbers, we're going to let the first number be x. So the difference between two numbers, x and y, the difference between them, the subtraction, is 9. The first number, so x, the first number plus, so that's the sum, so it's the first number plus twice the other number. So what are we going to have? Well, we already have x. 2y is equal to what? Is 27. So now we have our system, and we can play elimination. The elimination is not as straightforward as it was for the first two, though. So what are we going to do now? Which variable do we want to eliminate? Eliminate. Do you want to eliminate the y's or the x's? You can always eliminate either variable. Which one do we think might be the easier one? Maybe the x, because we can multiply through by a lower number. If we eliminate the y's, we have to multiply the top equation by 2. It's only 2, I know. It's only 2. But as a rule of thumb, go with the lower number, okay? So in this case, we can either eliminate the y's by multiplying the top equation by 2, or we can eliminate the x's by multiplying the top equation by -1.
2, it's already negative. Yeah. It's already negative.
So That's fine. So we can eliminate the y's. Either one you guys want to do. Eliminate the y's by 2, by multiplying by 2. So we're going to multiply that first equation by 2. So 2 times, and make sure you always put the entire equation in parentheses. 2 minus y is equal to 9. And now we're going to distribute this to all three of those terms, so that we're left with 2x minus 2y is equal to 18. So that's our new equation. So this is our result. Now we want to take the result and we want to add that to the second equation. So add the result to the original second equation. So the result is 2x minus 2y is equal to 18. And we're going to add that to the original second equation. X plus 2y is equal to 27. We're going to add those two together. And when we add them together, we get 3x plus 0y is equal to 45. This leaves us with 3x is equal to 45. Divide by 3. Divide by 3. X is equal to 15. So that's one number. One number is 15. So as we've done with the other ones, we have to substitute x equals 15 into, which equation do you want to substitute it into? Either one. What's the easier one? The one with the lower numbers. It's going to be the first equation, because you have a 9 and you have a 2. You have a 2y and a 9 instead of a, you have a -1 and a 9 instead of a 2 and a 27. So they're just lower numbers. So we just choose the one that has the lower numbers so that you get nice easy multiplication. And that will give us 15. 15 minus y is equal to 9. Yes. So 15 minus y is equal to 9. We can add 15 to, subtract 15 from both sides, so that we're left with negative y is equal to -6. So now we divide through by -1, and we're left with y is equal to 6. So the two numbers that we were looking for, the two numbers are 15 and 6. So that's problem number 3. And let's do problem number 4. The sum of two numbers is 36. How are we going to set this up? So, addition. And what are we going to do? X plus y is equal to 36. So number 4 is x plus y is equal to 36. How are we going to set the second up? Twice the first number. So what do we have? 2x, twice the first number. So 2x plus, is it plus or minus? Twice the first number minus the second is 6.
I should be simple.
All right, so we have x plus y is 36, and we have 2x minus y is equal to 6. Which variable do we want to eliminate? I should have just written here minus y, okay? So which one can we eliminate directly? The y's. The y's just fall out directly, okay? So elimination of the y's. So we're going to add the two together directly. And we have 3x plus 0y is equal to 42.
Hold on, wait a minute. Okay, so you got 2x plus parentheses negative y equals c. It's from the 2x minus y.
So we're left with 3x is equal to 42. Divide by 3. Divide by 3. X is equal to 14. So the first number we're looking for is 14. And then we're going to substitute x is equal to 14 into the original equation. Which one do we want to substitute it into?
X plus y.
The top equation. Okay, so we're going to substitute this into the first equation because they're all just 1, 1, and then 36, so low numbers. And we have 14 plus y is equal to 36 minus 14 from both sides. Y is equal to 22. So we found the other number here. So the two numbers are 14 and 22. We're going to move on to number 6. Number 6 is this. So that was number 5. Number 4. We're gonna skip number 5 and we're gonna do number 6 because 5 and 6 are both very, very similar. Okay, I'd like to get a number 6 here. So let's read the problem here. The problem says, for number 6, the sum of two numbers is 25. So let's just go ahead and write that first equation out. So the sum of two numbers, x plus y, is equal to 25. One of those numbers is twice the second number plus 7. Okay, so this gets a little bit more complicated. One of those numbers is twice the second number plus 7. So we have one of those numbers. Let's just let x be x, okay? So x is x. Now what do we want to let y be? Well, one of those numbers was twice the second number. plus 7. So what do you guys think? One of those numbers is just itself, right? The other number is twice that number plus 7. So if x plus y is equal to 25, and one of those numbers, whichever one we want it to be, one of those numbers, so let's just say x, one of the numbers, it doesn't matter which one, just says one of them. One of them is twice the second number, so 2 times y plus 7. So one of those numbers, it's telling us that the sum of those numbers is 25. It tells us that one of those numbers, whichever one we choose, one of them, is twice the other number, which would be twice the y plus 7. Now we could have had that y is equal to 2x plus 7. It doesn't really matter which one you choose. So we can substitute this directly into the first equation now, right? Or do we subtract the 2y and then use elimination? Do you want to use the method of substitution, or do you want to use the method of elimination? This is set up directly for substitution. Because if we were to use elimination, we would have to move everything, move the x to the left side, move the y to the left side, and then add the 2 up and then use elimination. But we're already set up to just substitute this right in for x into the first one. So we're going to use substitution or elimination. Well, since this is already set up directly for x, we're just going to use substitution, okay? So we're going to choose substitution, and we're going to substitute 2y plus 7 plus y is equal to 25. We're going to combine like terms. So 2y plus y is 3y plus 7 is equal to 25. Subtract 7 from both sides, subtract 7, and we have 3y is equal to 18. Divide by 3, divide by 3, y is equal to 6. Well, if y is equal to 6, we now need to find x, right? So we have to substitute y into either one of these equations. Which one do we want to substitute it into? The first one. So what we have is x x plus 6 is equal to 25. Minus 6 minus 6. X is equal to 19. So we have our two numbers. The two numbers are 19 and 6. Two numbers are 19 and 6. Why don't you guys try to, on your own, try to set up number 5. The sum of two numbers is 20. Well, that's pretty straightforward. And then the second equation is a little trickier to set up. So I'll give you guys just about 2 minutes to try to set them up, and then we'll solve it together, okay? The sum of two numbers is 20. The difference between 3 times the first number, so what do we think that first number is going to be? 3x. And twice the second number, what's that going to be? The difference is, so 2x minus 2y. All right, so let's go ahead and set that one up here. So number 5. The sum of two numbers is 20. The difference, so the subtraction between 3 times the first number, 3x, and twice the second number is 40. Now we have to eliminate a variable. Which variable do you want to eliminate? Yeah, y is the easiest one, right? And how do we want to eliminate y? By multiplying the first equation by what? 2. Don't forget to just offset the whole equation in parentheses, and then make sure you distribute that 2 to each of those 3 terms. And so what we have here is 2x plus 2y is equal to 40. That's the result. And we want to add, distribute, and add the result to the second equation. Add the result to the second equation. So we have x 2x plus 2y is equal to 40. And we're going to add that to 3x minus 2y is equal to 40. We have 5x plus 0y is equal to 80. We're left with 5x is equal to 80. So x is equal to 16. So that's one of our numbers. And then the second number is going to be by substitution, so we're going to substitute. Substitute x is equal to 16 into what? The first or the second equation? Into the first equation. And so if we substitute that, we have 2 times 16 plus 2 times, no, it's just we're going to substitute this into the first equation, the original equation, okay? So scratch this, and we're going to substitute 16, well, the original equation here. I was looking at the result, so let's use the original equation. We can still use the result, but let's just get in the habit of using the original equations. The original equation is x plus y is 20, so we're going to substitute 16 plus y is 20. Plus y is 20. Minus 16, y is equal to 4. The two numbers are 16 and 4. Now let's go to the back. The back of our handout it says the cost. So now we're switching gears and we're going into an actual word. These are all word problems, but now we're going to be dealing with, I guess, different objects instead of numbers. Okay, so where we were just doing numbers before, we're going to be dealing with objects. So for a lot of people, this is a little more challenging. And it says here that the cost of 3 boxes of envelopes and 4 boxes of notebook paper is $13.25. We have 2 variables. We have boxes of boxes of envelopes and boxes of notebook paper. So envelopes and notebook paper. Those are our 2 variables. Which one do you want to be the x variable? Boxes. We're going to let boxes, we're going to let envelopes equal x, and we're going to let notebook paper equal y. So now we have our 2 variables, okay? So we have 3 boxes of envelopes. Well, if one box of envelopes is just x, then 3 boxes would be what? If one box of notebook paper is just a box of notebook paper is our x variable, then 3 boxes would be what? It's 3x. Thank you. So 3x. So let's set up our equations now. So we have 3x plus 4 boxes of notebook paper. Well, if notebook paper is y, then 4 boxes is plus 4y. And that's going to be equal to 13.25. The second equation says 2 boxes of envelopes. Well, 2x, and 6 boxes of notebook paper plus 6y is equal to 17. Find the cost of each. So we have our systems of linear equations here, and we have to now go through the process of eliminating a variable and then the rest of it. But so the first step here is to eliminate a variable. Which one do we want to eliminate? The x's? Yeah, because you're dealing with 3 and 2 versus 4 and 6. So just always go with lower numbers, okay? Just these are easier multiplication. So 3 and 2 is easier to work with. We're going to multiply the top equation by what? By the 2. Is it going to what? Both of these are positive, so something has to be negative. Negative 2. So negative 2 times 3x plus 4y. Okay, let's just set them both up first so that we don't lose sight of what we're doing. So let's skip a little bit here, and we're going to multiply the bottom one by what? It's 3. So 3 times that. So now that we have them both set up, let's just go and let's just work them now. So again, we've got to distribute each of these to everything, okay? So let's work through this. So we have minus 6x minus 8y, and it looks like we have 2650, so negative 2650. And for the bottom, we have 6x, we have 18y, and that's going to be equal to 51. So now that we have our results, yes.
I got a question. So why on this equation you multiply you multiply this or both this equation by different numbers?
Yep. Because up here in the original equations, remember we're trying to eliminate a variable. We're still playing elimination. That's never going to change for us when we're solving systems. That's always the first thing you always do. But we have a 3x up here and a 2x down here. We want to eliminate a variable, so we choose x. Well, we have to get them to be the same numbers but opposite signs. And so the only way to get both of these x's to be the same numbers, the lowest number we can get them to be the same is 6. We can have 6x here and 6x here, but one of them's got to be negative. So the only way to get that is to multiply the top by 3x by 2 and multiply 2x by 3 so that we end up with 6x apiece. One of them has to be negative, so we just choose the 2 to be negative. We could have chosen the 3 to be negative and the 2 to be positive. It doesn't really matter which one you choose to be negative or positive. It just, the result has got to be to where when you add them together, you end up with a positive or a negative, and then ultimately 0. Okay, so you're going to see that now because we're going to add the results together. So add the results together. And when we add the results together, we have minus 6x minus 8y is equal to negative 26.5. We have positive 6x plus 18y is equal to 51. So when we add them together, we get 0x plus 10y, and that's equal to what? Huh?
78.5.
Well, we've got a negative 2650 and a positive 51. (51) minus 27 is 24, plus a 0.5 is 24.5. So 10y is equal to 24.5. Divide by 10, divide by 10. Y is equal to 2.45. Just move that decimal place over one time. So y is equal to $2.45. Well, what was y? The y was notebook paper. So a box of notebook paper is $2.45. We have to find how much a box of envelopes is going to be. So a box of envelopes now is what? Let's substitute. We play substitution.
Did we turn this in?
Let me finish here, okay? So I've got to finish up quick. So let's play substitution. So we're going to substitute y is equal to 245. So we have, let's choose the bottom equation. So we have 2 times x, so we have twice x.
You mean x equals 2.45?
Well, we eliminated the x's. We're left with y. So 2x plus 6 times 2.45. Can somebody do that calculation? Is equal to 17. What's 6 times 245? 14 point,
12.47.
huh? It's 14.70. So we have 2x plus 14.70 is equal to 17. Subtract 14.70 minus 14.70. So what's 17 minus 14.70 is 2.3. So 17 minus 14.70 is going to be 2.30. So we have 2x is equal to 2.30. So divide by 2, divide by 2. So we have $1.15. So x is equal to $1.15. That's how much a box of envelopes costs. So what we have is we have a box of notebook paper. A box of notebook paper is equal to $2.45. A box of envelopes is equal to $1.15. These are long problems. Hopefully you would only get one of these on your test. That you would probably get, maybe if you're going to get anything, get a couple more of the number problems. Okay?